Hello, welcome to the extension of session number 2. We solved this one last and I want to move to this other one. Yeah, this is just an extension because I've realized if the video is too long, then loading it or uploading it on YouTube is not that possible. Okay, so question number 12. The figure below shows a power source connected to a variable resistor of resistance 12,000 ohms. The resistance between the points A and C is 1/4. The resistance between point A and B. The resistance between point A and C is 1/4, 1/4 of the resistance between A and B. Okay. Write the use of a potentiometer. What is the use of a potentiometer? Yeah, so the use of a potentiometer, what does it do? Like in this case, what will we get from this one? And because it's like a potentiometer. So it is to do what? To provide a variable potential difference in a circuit, or to vary the potential difference in a circuit. So we can just say to vary the potential difference so you can always write potential difference in a circuit. Yeah, the potentiometer, it can always give us a given potential difference in a circuit, what we want in our circuit, or what we want as the output. Okay. Part B, calculate the current I in the circuit. The current I in the circuit. How do you get current? That is what you need to think first. Or how can we get current? So because I'm seeing we have some resistors here, and I'm seeing we have a power source. So most likely we'll rely on V is equals to IR. And I will be equal to V over R. Do we have the V? Yes, we have the V. What about the R? Okay, we have some R's here, but we can't use them the way they are. Because this current, our I is coming, when it gets here, it's now dividing itself into two parts. So unless we get the current here and the current coming here, then from there maybe we can add them to get this. Alternatively, we can combine these two. We can combine this one with this other one. And then we form one resistor. From there we'll have one resistance, and then we have the potential difference. No, and then we have it will be the same as the potential difference across it. Then we can calculate the current. So look at this one. From A to C, they have said is 1/4 of from A to B. So let's get the resistance R from A to C. Resistance from A to C is given by 1/4 times 12,000. So 1/4 times 12,000, what do you get? Yeah, it's like dividing 12,000 by 4. So you end up with 3,000 ohm. So here is 3,000 ohm. The resistance from here to here. So let me just make this one and then write 3,000 ohm. Do you know why we are getting that one? Because we want to combine them. If you want to combine them, you must know that this one, the 6,000 ohm resistor, is specifically in a parallel connection to the one between A and C. So you combine this and this, but now using what? The parallel way, because they are in parallel. Then from there, after bringing these two together, we'll now come and add them to this. Yeah, it's like you have a circuit where you have a resistor, and then you have another one, and then you have this, and then you have another, and then from there, of course, we have the power supply. I'm sorry for the drawing, is not that beautiful, but you can make one. So this one is R, this one is A, C, then this one can be from C to B. Yeah, so we have realized that this one is 3000. So if this is 3000, 1, 2, 3, and this is 6000, 1, 2, 3. So you combine the two first, and then from there we'll add them to this one. By the way, from B to C now will be, so if you want to get this one, then you just subtract, because the whole thing is 12,000. So from B to C will be 12,000 minus 3,000. So you end up with 9,000. So this is 9,000. So we want to get a single resistance here. Yeah, you can run around with it now. So let me use the long way. So 1 over the resistance R, and that is the total R, and RAC will be equal to 1 over 3,000. Okay, should I start with the other one? Over 1 over 6,000. Yeah, I'm adding these two. So you end up with what? So 1 over 3,000 plus 1 over 6,000. So you get 1 over 2,000. Yeah, 2, 1, 2, 3. So if you want to get the combined resistance R and RAC, you get the reciprocal. So it's going to be 2,000 ohms. Good. So we have this combined. If you combine these two, we get 2,000. Now from there, we combine them with the one from C to B. We combine them with the one from C to B. So the total the one from C to B with this other two, the combined two, are now in which connection? They are now in a series connection. So we just add them. So we'll have the 2,000, we add to 10,000, we end up with 11, 1, 2, 3. So the combined resistance of all this now is going to be 11,000. So it's like you have a current I, then we have a voltage 220, and this is the resistance. So if you want to get your I, we go back to I is equals to V over R. Our V is 220, our R is 11, 1, 2, 3. Yes, so you will have 220, you divide by 11,000. So what do you get? So you get your I. So what are you getting from your side? Do you have a working calculator? So you get 0.02 amperes. Yes. I hope you're getting what's happening. And how is the lesson? Is it interesting by any chance? Yeah, I hope you're enjoying it from that side. So that is how you get I. The key thing here was just combining them. I know we have other ways that you can work on the same thing. Yeah, we have other ways, but that is the easy